Hello friends, welcome to ML with AP. This is the video 2 of the series of videos where we are discussing descriptive statistics. The topic for today is mean. Let's learn. Just a quick recap. If you have not watched my previous first video on descriptive statistics, I strongly recommend you to go ahead and watch. Descriptive statistics mainly deals with two aspects of the data, central tendency and dispersion. Let's take central tendency first. Central tendency deals with the location of the data. What is that one number which appropriately represents where the data is mostly located? Okay, there are different measures for central tendency. Mean, median, mode are the most common ones which we are going to discuss. At the other hand, dispersion deals with how widespread the data is. It is a representation of the variability associated with the data, how widespread or how narrowly spread the data is. The various measures or the metric associated with dispersion are variance, standard deviation, range, skewness, and kurtosis. Today we are going to learn about mean. When we talk about mean, the one thing which comes to our mind is average. That is just one type of mean. In statistics, we have arithmetic mean, which is average, but we also have weighted mean, we also have geometric mean, and harmonic mean. We are going to deal everything today. Let's first deal with mean, arithmetic mean. This is the most common and most commonly understood mean. This is what in common language we call average. It is very simple and straightforward. If we have given a bunch of 8 numbers like this over here, and if I ask you to calculate the arithmetic mean, what you are going to do? We are going to sum them up over here and divide by the number of numbers. So the sum is 102. There are 8 numbers. We divided by 8. 12.75 is the arithmetic mean, or average as we call it. That's what arithmetic mean or the first mean is. Let's try to understand the notations which is associated with that. Now, I have dealt with population, what is population and what is sample in my first video. Please go ahead and watch it if you have not done so. Population in simple terms would be that all the data which is associated with an event, if we are accounting for that, that is called population. Sample is something when we are taking a subset of data only and we are doing a prediction about the population, that is called sample. Okay, now why there is a notation difference over there? In statistics, when we are dealing with population, the formula remains the same. The way it is depicted or notified is slightly different. When we are calculating a population mean, we usually represent it with a Greek mu character, and if we are talking about the sample mean, and if we are calculating the mean, arithmetic mean of a sample, we represent it by x bar. Similarly, over here, the capital N denotes the number of items in the population. If we are dealing with population, we usually represent the number of items with capital N. On the other hand, if we are dealing with sample, we represent in a small m. These are notational difference. The formula still remains the same. You have to add everything up, divide by the number of the elements. Okay. Now, in case of population, in mean, we have seen how mu and x bar is represented. Similarly, for standard deviation also, the sigma and a small s. So these are various notational difference which you have to bear in mind. Now let's take another example to understand arithmetic mean one more time. Here I have taken an example, and this is a toy example, and it will be a running example throughout this series of videos. In a particular college, the first column represents the roll number of the students. So I have taken the sample of 15 students over here, and these are the placement packages in lakhs per annum. So the first student with roll number 1 got 3 lakh per annum package, second one got 4, third one got 6 lakhs per annum, fourth one got 7 LPA, and various. One important thing to note is that 10th roll number got lucky and he got a US placement, so probably he got a 100k salary in US dollars, which is converted into Indian rupees is like 80 lakhs. So you can see there is a big number which is present over there. Okay, now if we have to calculate the mean, how we are going to do? We are going to sum all these numbers over here and divide by how much? Divide by how many? Divide by 15. If we sum everything, divide by 15, that comes at 10.33 lakhs per annum. So, friends, if somebody asks you that what is the arithmetic mean of this class of a student, let's say this was a class of a student, what is the arithmetic mean of the placement package? It was 10.33. Now let me ask you a question. Should this mean be called mu or x bar? Is it a population or is it a sample? How should we represent it? The answer is it depends. Why? Suppose we are treating this as a population itself. Let's say this is a PhD program. There were 15 students in a class in a PhD program and all of them got placed after completing their PhD. In that case, this will be the population. But let's say this is a placement package details of an engineering college where 1,000 students are studying, and we are just taking a sample of 15 out of it to predict what is the average salary which a student from that college would get, right? If that is the question or that is the context, in that case, this should be represented as a sample mean, which is x bar. Friends, I hope this is clear. Let's move on. Now the second type of mean is weighted mean. Weighted is mean nothing but arithmetic mean in a different form. How? Let's see. This is our initial data set, right? The 15 students, their roll numbers 1 to 15 and their packages in lakhs per annum. We know the arithmetic mean came as 10.33. Let's represent this data in a slightly different form. We'll represent in a frequency table. So the first column will represent the salary figures. So the 3 lakh salary, 4 lakh salary, 5 lakh, 6 and 80 lakh. How many, the second column will represent how many students got it. So 3 lakh salary were received by 3 students, 4 lakh salary were received by 3 students, 5 lakh salary by 1 student. We can see it from the table. So we have just rearranged this data in the first 2 columns differently. Here, each of the individual items are listed individually on an individual row. Here, we are summing them in a way that this is essentially what frequency table is there. The second column represents the frequency of salary. The first column is the salary itself. Okay. How to calculate weighted mean? What we are going to do is we are going to multiply salary with number of occurrences or number of students got that salary, right? So 3 lakhs per annum were received by 3 number of students. So the salary into number of students will be 9. We'll do the similar thing for everything and then we'll divide it by the total number of students over here in the second column. Again, the weighted mean will also comes 10.33, same as arithmetic mean. Friends, if you notice, we are not doing anything differently in weighted mean. Here, we are accounting 3 plus 3 plus 3 times, right? What we are doing over here? 3 into 3, 9. So whether we are representing it in a frequency table and calculated weighted mean or represented it in an individual form and calculated arithmetic mean, it's one and the same, right? The formula for weighted mean is, again, the column second, the number of occurrences of students or the number of students which are getting, these are called weights. So the formula is weight multiplied by individual observations or the rows, this salary divided by total number of weights. So this sigma summation notations, if you see, this is the summation of all the weights. In this particular case, it will be the denominator will be 15. This will be WIXI will be WI is this one, number of students. XI is the individual salary, right? So 3 into 3 plus 3 into 4 plus 1 into 5. Okay. So this is how we calculate the weighted mean. Let's move on. Now geometric mean is slightly different. It is different from the arithmetic mean or weighted mean. How? Let's see. In case of this is the same example, we have 15 students and their LPA placement package in LPA, right? Instead of adding them up as we do in the arithmetic mean, what we are going to do is we are going to multiply each of these items, okay? So we'll multiply 3 into 4 into 6 into 7 into 3 into 6. So here we are multiplying. And since we are multiplying, We are not dividing by the total number of students, which is 15. We are taking a 15th root, nth root of that element where n is 15. Okay, so just to recap over here one more time. In a case of geometric mean, we are going to multiply each of these observations, and then instead of dividing how we do it in the arithmetic mean scenario, we are going to take the nth root of the element. So the nth root of x1 to xn is the generic form of getting a geometric mean. In this particular case, we'll multiply each of these elements with each other, and then we'll take the 15th root of that, and then geometric mean will come at 6.05. Remember, arithmetic mean was 10 something. Geometric mean is slightly lower than that. Okay, now geometric mean intuition. Geometric means doesn't give intuitive explanation that what it is. Arithmetic mean means makes sense that okay, this is the average number. Okay, I have added them and then I have divided it by the number of elements. There is a geometric interpretation of geometric mean which we are going to see. Let's say we have a rectangular plot of land, 9 meter by 4 meter. 4 meter is the width, 9 meter is the length. Now, geometric mean represents that give me a square which has the same area as this rectangle, having length as 9 and width as 4, and what would be the side of that square, right? So let me repeat one more time. Let's say we have a rectangle of 9 and 4 dimensions. Geometric mean means that of the same size as this rectangle, if it were a square, what would have been the side of that square which has the same area as the rectangle? Okay, this is the geometric interpretation of geometric mean. So if let's say my rectangle was 9 into 4, 36. 36 is the area, right, of this rectangle, length into breadth. For 36 area, if I have to draw a square, what would be the side of that square? Obviously, the side of the square has to be 6 into 6, right? 6 into 6 becomes 36. A square, the side of the squares, is the area. Side square is the area for the square, right? So similarly over here, 9 into 4, 36 for the rectangle. N is 2 over here, right? Why n is 2? Because we have 2 dimensions over here. We only have 2 numbers to calculate the geometric mean. And the square root of that, because n is 2, so we are calculating a square root, and a square root becomes 6. So the geometric mean of 9 and 4 is 6, right? And this is the geometric interpretation of that. You can expand this into 3 dimensions, 4 dimensions, 5 dimensions. Let's see, in 3 dimensions, it becomes a volume, right? Suppose we have a cuboid with the shape 2, 4, and 8, right? Height, width, and length. 2, 4, and 8. Now, the question for the geometric mean would be that give me a cube of the same volume, and what would be the side of that cube would be the geometric mean of 2, 4, and 8. So the volume of 2, 4, and 8 cuboid is 8 into 2 into 4, LBH, 64. N is 3 because it is 3 dimensional. I have 3 elements to calculate. So I have done a cubic root of 64, which became 4. So in other words, a cube of 2, 4, 8 dimension has the same volume as 4, 4, 4 dimension, as a cube of 4, 4, 4 dimension. That's why the geometric mean of 2, 4, 8 is 4, right? This is the geometric interpretation. You can expand this onto 4 dimensions, 5 dimensions, 6 dimensions, and you can keep doing the nth root of that, and it makes sense. We cannot visually define those higher dimensions in very good pictorially, right? So we probably will leave it at the 3 dimensions, okay? Now that was the geometric interpretation. Let's take another intuition which is more relevant to us for the real world, right? Let's say you have 100 rupees and you wanted to put that in a fixed deposit, okay, in a bank, in some bank, okay? Now the bank is saying that the first year I'm going to give you 5% interest. On the second year, I will give you 10% interest. third year 12% interest, and the fourth year it will become 15% interest, right? This is what the bank is giving you on the fixed deposit. Now you have 100 rupees you deposited for 4 years. First year with 5% interest, your money became 105 rupees, right? No problem. This 105 rupees gained 10% interest and became 115.50 rupees in the second year. At 12% interest in the third year, this your 115.50 rupees became 129.36 rupees. Fourth year, you were getting bank was giving you a 15% fixed deposit interest, right? So 129.36 rupees became 148.76. So at the end of 4 years, your 100 rupee became 148.76, right? And what was the FD rate of interest? 5% for the first year, 2% for the second year, 3% for the third year, and 15% for the fourth year. Now the question is very simple. The question is, can you give me a static rate of interest instead of this variable rate of interest, and so that I will achieve the same figure at the end of the 4 years, right? So just to reiterate the question, right? What is my average rate of return over a period of 4 years? Or what a bank should be given instead of this variable rate of interest? If that would have been a fixed rate of interest, what that rate of interest would have been? This is what geometric mean is all about in terms of, if you have to think it in this term, right? So it appears that you have to multiply 5 into 10. You have to take a geometric mean of this 5 into 10 into 12 into 15, and then take a fourth root of that, and that give you the answer as 9.74. What does it mean? That if a bank would have been offering 9.74 fixed rate of interest for the entire 4 year, I would have still gotten on my 100 rupee investment at the end of 4 years, it would have still gotten to 148.76 rupees, right? That's why this variable rate of interest or the geometric mean of 5, 10, 12 and 15 is 9.74. This is another way or another intuition or other way of interpreting geometric mean. Okay, friends, I hope this is clear. I will pause the video over here. In next video, we are going to deal with median and mode.